Welcome back, everybody, to another deep dive. This time, we're taking a look at something pretty fascinating coming out of Google.
Oh, yeah.
It's an open source project that lets you connect, those LLMs, those large language models that everyone's talking about, to databases.
Really?
Yep, we've got the code documentation and even deployment instructions.
Yeah.
Oh, and even code of conduct.
It
So
sounds pretty comprehensive.
it is, and it feels like we're really kind of on the edge of something big with this.
I know what you mean. Yeah?
Just imagine all that language power of these LLMs with a database constantly being updated behind it.
You're not just theorizing with this, though. You can actually get your hands on this project, adapt it, experiment with it. I mean, the possibilities are pretty exciting, really.
Okay, so let's unpack this a little bit.
Right.
First off, what exactly IS this?
Gen AI database retrieval app.
Yeah, what exactly IS this Gen AI database retrieval app?
Yeah. What exactly is this Gen AI database retrieval app?
Yeah.
That's a mouthful. It is a mouthful. Well, the name's pretty descriptive, actually, and you can find it on GitHub, of course, because it's open source. Right now, it's just a demo, but the whole point of it is to show you how to connect any LLM to pretty much any database that you want.
I'm guessing that's important because, you know, not every listener is using the same kind of database.
Yeah.
Some might not even be using a cloud database.
Exactly, exactly. And this project really does kind of walk you through the different setups, different databases, whether or not you're on the cloud. They've even got this fictional airline, Symbol Air, that they're using as a use case.
Okay.
So imagine asking a chatbot uh, about a flight delay, but instead of just getting kind of generic answers, it pulls up your specific booking details
Uh-huh.
and gives you personalized options based on that.
Okay, now that's starting to feel really useful.
Mm.
But we're talking about combining two very complex things here. LLMs and databases. How does that actually work?
Well, that's where the AI magic really kind of comes in, and it's pretty clever actually. The app uses these two techniques: Array, which stands for Retrieval Augmented Generation, and then there's ReaCT prompting.
Acronyms galore. I know what prompting is in general, but RAY and ReaCT, these sound pretty specialized. Can you break it down for us?
Sure. Let's start with R. Think of it this way. An LLM on its own is limited by the data it was trained on.
Okay.
So it's kind of static in that way. But Array allows it to actually tap into your database in real time.
Okay.
So if you ask it a question about something very specific, Array is how the LLM can go and find that exact information to give you a really accurate answer.
So it's not just making the element smarter. It's
Yeah.
it's kind of like giving it access to a whole new level of information it couldn't have before.
Exactly. Exactly. So now ReaCT prompting. This is about transparency. You've probably heard of LLMs, hallucinating, right? Making stuff up.
Yeah, it can be a bit of a wild card sometimes.
Well, ReaCT is like giving the LLM a thought process that we can actually follow along with.
Okay.
So it doesn't just spit out an answer, it actually shows its work. Like first I need to find this data, then I'll compare it to that. And based on these criteria, my conclusion is, that kind of step-by-step reasoning makes it way more reliable.
So instead of just trusting the LLM blindly, we can actually see how it arrived at its answer, and that makes you feel a lot more trustworthy, especially when you're making important decisions based on this information.
Precisely. So Argy gets the LLM the right information. ReaCT makes sure it uses that information logically. And together they just make this whole system incredibly powerful.
Okay, I'm with you so far. I'm imagining a lot of moving parts behind the scenes to make this all happen. So how's this whole thing structured?
Well, there are three main components to the architecture. First, you've got the application itself. You can kind of think of this as the user interface. It's, where you actually interact with the LLM.
Okay.
So this could be a chatbot, a search bar, anything that kind of takes in your input.
Got it. So that's the front end, kind of what the user sees. What's going on, kind of behind the curtain, behind the scenes.
Right. So then you have the retrieval service. This is kind of the real workhorse, right? The retrieval service actually talks to your database.
Okay.
So the application says, hey, I need information on this, and the retrieval service knows exactly how to go and find it in the database.
So the retrieval service is like the translator between the LLM world and the database world.
That is a great analogy, actually. And the cool part is this project is designed so you can use pretty much any database you want. AlloyDB, Cloud SQL, even a regular Postgres setup if you're not on the cloud. You just pick what works for you.
That's pretty flexible. So I give the app my question. It talks to the retrieval service. The retrieval service fetches the information from my database, and then the LLM uses all of that to give me an answer. Is that basically the whole flow?
That's the basic flow. But again, it's all powered by this really clever combination of RAG and ReaCT that makes it so much more than just a, basic question answer system.
Okay, it's really clicking for me now. I'm starting to see how powerful this could be for, all sorts of applications.
Absolutely, absolutely. And what's even more exciting is how accessible they've made it. Deploying this app might sound intimidating, but they've broken it down into these very clear steps. And
Speaking of deployment, I'm curious about something. I noticed there's a code of conduct for this project. That's not something you see every day, with tech stuff.
yeah, and that's a really important point, actually. This isn't just some code that, was dumped online. It's a community-driven project. They really want to make sure it's a welcoming space for everyone, regardless of, your background or experience level.
It's about fostering that collaboration and making sure everyone feels comfortable contributing to it.
Exactly. It emphasizes using inclusive language, being respectful of different viewpoints, and gracefully accepting constructive criticism, which, when you think about it, it's really crucial in a field as complex and rapidly evolving as AI is.
And it sounds like they're really focused on building a strong and diverse community around this project.
They are, and that's a good sign. Diverse perspectives lead to better solutions, and in a field as impactful as AI, that's incredibly important.
This is all incredibly fascinating. We've gone from what seemed like a pretty complex concept to a real world project with a strong community behind it. Before we move on, let's pause here and just recap what we've learned so far.
Sure. Well, we've established that the GenAI database retrieval app really demonstrates how to connect these LLMs to databases to make them even more powerful and accurate.
Yeah, and we've learned about the two key AI techniques that it uses: RAG for research and ReaCT for transparent reasoning. And that really sounds like a big part of what makes this project so unique.
Right. We've also discussed the three main components of the AXE architecture: the application, the retrieval service, and the database. And importantly, we've highlighted that the database is interchangeable, so that gives you the flexibility to use, whatever your preferred setup is.
Right.
And finally, we touched on the code of conduct, which really emphasizes the importance of a welcoming and inclusive community for this project. It's encouraging to see that level of commitment to responsible development in the AI space.
Wow, we've covered a lot of ground already. I'm eager to dive a little deeper into the specifics of how this app can be used. But first, let's take a quick break.
Sounds good. We'll be back in a moment to explore the deployment process and see how you can actually get started with this exciting technology. Welcome back. So we've laid the groundwork. Now let's get our hands dirty and see how this GenAI database retrieval app actually works, in practice.
I'm ready to see this thing in action. But before we jump into deploying it and all that, can we talk a bit more about those database options?
Yeah.
You mentioned there were a few to choose from.
Right, and that's one of the strengths here. They've made it compatible with a range of popular choices. So, for example, if you're working on Google Cloud, you could use AlloEDB. It's designed for high performance applications. So if you've got massive amounts of data, that might be the way to go.
So for a large company, or a project that just needs super fast processing, AlloDB would be a good fit.
Exactly. Then you have Cloud SQL, which also comes in those the Postgres and MySQL flavors. That's a great option for folks who want that managed service experience.
Okay.
Where Google takes care of a lot of the back-end complexity for you.
Makes sense, yeah. Cloud SQL is pretty popular for its ease of use. But what about those of us, who aren't using cloud databases?
Yeah.
Do we have options too?
You do. They've made sure to include instructions for setting up a non-cloud Postgres environment, like with AlloEDB Omni.
Okay.
So you've got that flexibility there, whether you're on the cloud or running your own infrastructure.
I'm sensing a theme here.
Yeah.
They've really prioritized making this accessible to as many people as possible.
It seems that way. And that's a good thing, right? For open source.
Yeah.
The wider the adoption, the more people that can contribute, build on this foundation. So
okay, so we've got our database sorted. What are the actual steps involved in deploying this app?
okay, so they've broken it down into three main stages. First, you got to set up your database. So create the instance, configure it, and most importantly, load it with, all that data you want your LLM to be able to access.
So if I was building that Symbol Air chatbot,
Yeah.
this is where I'd feed it all the, all the flight schedules and customer information, baggage policies, all that good stuff.
Precisely. It's all about making sure that the database is primed and ready for those LLM queries. Then you deploy the retrieval service, which is all about, connecting it to your database. Basically, you're giving it the roadmap to be able to find the right information.
It sounds like this retrieval service is the real key to unlocking the power of this whole system. It's like the bridge between the language model and the data itself.
Absolutely. And they've provided, clear instructions for each database type so you can get that connection configured correctly. Once that's done, the final step is actually running the application itself.
So this is where the user interacts with the LLM, asks their questions, gets their answers. It's like the front end of the whole system.
Right. And behind the scenes, it's coordinating with the retrieval service and the database to make sure the LLM has all the information it needs to provide those accurate and relevant responses.
Okay. So let's walk through like a hypothetical scenario here.
Hmm.
Imagine I'm using that Symbol Air chatbot, and I want to know if I can change my flight.
Okay.
What happens like behind the scenes?
Yeah. Okay, so first you type in your question. The application, it sends that over to the LLM. Now the LLM, thanks to that ReaCT prompting, it starts thinking out loud. It might say to itself, okay, this user wants to change their flight. First, I need to identify their booking. Then I need to check the airline's change policies. Finally, I'll present the user with the available options based on that data.
So the LLM is laying out its thought process step by step, almost like it's talking us through its reasoning.
Exactly. That transparency is a big part of what makes ReaCT so valuable. Now, to actually find your booking and the relevant policies, it needs to access the database, right? That's where OGG comes in.
Okay, so REGS is the one that's figuring out how to translate, my question. Can I change my flight into
Right.
something that the database can understand?
Right. It identifies the key pieces of information needed, your name, your booking number, the date of the flight you want to change, and it tells the retrieval service where to actually find that data in the database.
It's almost like R is highlighting the relevant sections of the database for the retrieval service to focus on.
Great way to put it. So the retrieval service then grabs that information and feeds it back to the LLM. Now, armed with your booking details and the airline's policies, the LLM can determine if a change is possible, what fees might apply, and present you with, a clear and concise answer.
Wow, so we've gone on a whole journey there from my initial question to the LM's thought process to the database search and finally back to me with a personalized response. That's
Yeah.
pretty impressive.
And that's just one example. Think about all the other questions that a chatbot could answer: baggage allowances, seat selection, even gate information.
Or imagine scaling this up, using it for internal knowledge bases at a company, or even for research purposes. I mean, the possibilities just seem endless.
They really do. They really do. But, it all starts with understanding the core components.
Yeah.
The application, the retrieval service, the database, and that clever interplay of RAG and ReaCT.
Okay, so we've seen how it works in practice, but let's talk about those who might want to take this even further. This is open source after all. Can developers build on this project, create their own custom retrieval services, or even connect it to completely different types of databases?
Absolutely. Absolutely. This GenAI database retrieval app, it isn't just like a one-size-fits-all solution. It's more like a blueprint for innovation.
Okay.
They've laid the foundation, but they encourage people to take it and run with it.
So it's like they've given us this set of powerful tools, but it's up to us to figure out how to use them to build something amazing.
Right.
That's the beauty of open source, right?
Exactly. It fosters collaboration, it sparks creativity, and it leads to solutions we might not have even imagined before.
This has been a truly insightful deep dive. We've not only explored the technical aspects of connecting LLMs to databases, but we've also seen how it works in practice, and even glimpsed the vast potential for customization and innovation.
It's exciting stuff. And in the next and final part of our deep dive, we'll step back and look at the broader implications of this technology. What does it mean for the future of AI? How might it change the way we interact with data and build intelligent systems? We'll explore all that and more after a quick break.
We're back for the final part of our deep dive into Google's GenAI database retrieval app. We've covered a lot of the how-tos, but now I'm curious about the so what. What does this project tell us about, the bigger picture of AI and how we might use it in the future?
Well, what's fascinating here is we're really seeing this fundamental shift. For a while, LLMs were all about, the language itself, writing text, translating, that sort of thing. But this project, it shows how we can actually make them interact with the world in a much deeper way.
Because it's not just about language anymore. It's about connecting that language
Yeah.
to real up-to-date information.
Exactly. And that just opens up a whole new set of possibilities. Instead of just asking an LLM, a general question, you can ask it to analyze, your specific sales data or to generate a report based on, the latest findings in your field of research.
It's like giving the LLM a direct line to the information it needs
Yeah.
to be truly useful.
And that has huge implications for how we actually build, AI applications going forward. We can start to create systems that are much more dynamic, responsive, and personalized.
Okay, so I'm picturing this. A doctor is trying to diagnose a patient with a rare condition. Instead of just relying on textbooks or general medical databases, they could use an LLM connected to a database of the latest research papers, clinical trials, even anonymized patient data from around the world.
That's a perfect example. And because it's using Ray Walker-Yassity, the LLM can, show its work, explain how it arrived at its diagnosis and what evidence it's basing its conclusions on.
That would be a game changer, not just in medicine, but in any field where, having access to the most up-to-date information is crucial.
Absolutely. Think about, financial modeling, legal research, even urban planning. The ability to connect LLMs to these dynamic data sets could revolutionize the way we approach, these complex problems.
It's incredibly exciting. But I have to ask, are there any potential downsides to all of this?
Yeah.
Giving an LLM access to so much data, it feels like there could be risks involved.
Yeah. That's a great point. And it's definitely something we need to be mindful of as this technology develops. Security is paramount, of course. We need to make sure that these databases are protected from unauthorized access.
So safeguarding the data itself is crucial, especially if we're talking about sensitive information like medical records or financial data.
Exactly. And
Yeah.
it's not just about, external threats. We also need to think about how to prevent misuse from within. Who has access to this data? How is it being used? Those are questions we need to be asking.
It sounds like a lot of responsibility comes with this kind of power.
It does. And that's why the open source nature of this project is so important. By making the code available for everyone to see and scrutinize, it encourages transparency and helps to ensure that these systems are being developed responsibly.
So it's not just about building cool technology, it's about building it in a way that benefits society as a whole.
Exactly. And that requires a collaborative effort involving not just, engineers and developers, but also ethicists, policymakers, and the wider community. We need to have a conversation about the potential impact of this technology and work together to create, guidelines and safeguards.
This deep dive has been a real eye-opener. We started by exploring the technical nuts and bolts of connecting LLMs to databases, and now we're talking about the future of AI and the importance of responsible development. It's been a really fascinating conversation, and to all of our listeners out there, I highly encourage you to check out this project. We'll include the links down in the show notes below, and we'd love to hear your thoughts. What are some of the ways you think this technology could be used? Until next time, keep learning, keep questioning, and keep diving deep.